So we are starting this lecture. This is electric field between two parallel charged plates. This is the continuation of the previous title. So I think the heading is already there. Electric field between two parallel charge plates. A very common simulation is a walk-through gate. A very common simulation is a walk-through gate. So when you consider a walk-through gate, you can model it like you can model it you can model it like this idea that when you are having two parallel plates. So this is the idea that this is an idea here. We have a field, we have uniform and non-uniform. A uniform field is shown by equally spaced parallel field lines. This is our first concept for today. There are two types of fields. One is called uniform and the second is called non-uniform. Now, what's the difference between uniform and non-uniform field? Uniform is something when the signal strength is the same. So, for example, you move in your house and you see the Wi-Fi signals are changing in strength. Then it is a non-uniform field. If you notice the Wi-Fi signals are not changing, the Wi-Fi signals are not changing. The Wi-Fi signals are fixed. It means that it's a uniform field. I repeat the first concept for today, that electric field is of two types: uniform electric field and non-uniform electric field. Whatever field, but the word uniform means same signal strength. Whatever field you are considering, it's a same signal strength. And when you have non-uniform field, it's basically the signal strength is changing. A uniform field is shown by equally spaced parallel field lines. So now you have to copy this screen. This is our first concept. The people who have just joined, so please note that we are continuing electric field. This is the second lecture on the title, and we are doing parallel field lines. There are two types of electric field. There are always two types of every field: uniform and non-uniform. Uniform field means the signal strength is not changing. Non-uniform means the signal strength is changing. Now look at this idea. Field strength remains constant and field strength varies. So commonly, a force fields are non-uniform. In our common life, whenever you look at the normal application, mobile signals and the Wi-Fi signal, they continuously change. So there are two types of field: uniform and non-uniform. Now you have to copy this also. So this is our first concept for today. Now let's move forward to our next concept. So parallel plates with opposite charges, parallel plates with opposite charges create a uniform field. Now look at this idea. This is the electric field between two parallel plates, just like the example I gave. Sorry, the best example is a walk-through gate. Now, these are the two parallel plates. The two parallel plates are actually facing each other. The two parallel plates are there, and within the region, the field lines are with each other. So now the lines are parallel, and the lines are parallel. So field lines are parallel to each other. So now you have to copy this diagram. This is called electric field between two parallel plates. Now this is a diagram. This is a diagram. This is a diagram showing the parallel field lines parallel to each other. The lines are parallel and equidistant. The lines are parallel and equidistant. Now look at the formula. E is equal to V upon D. Now this is the idea. Look at the formula. E is equal to Formula is E is equal to V upon D. Now the unit is volt per meter. We are doing electric field between parallel plates. The common simulation example is like walk-through gate. You find walk-through gate always when you go to these buildings and malls and etc. When you go through the walk-through gate, there are two parallel plates. There is a field there. It's not an electric field, it's a sensation field. And when you go through the field detects your presence and it can scan you. This is called electric field between parallel plate. Now look at this concept. Now if the field is uniform, the lines should be parallel. Our next concept for today. If the field is uniform, the field lines should be parallel. Look, these lines are parallel except on the corner. The lines are bulging at the corner, but overall the lines are parallel. Now look at this diagram. Left side is a uniform field and right side is a non-uniform field. If the lines are parallel, it's a uniform field. If the lines are not parallel, it's not a uniform field. Now comes to our sketch. Voltage against D. Achha, now look at the diagram. This is V. V is the potential between the plates and D is the separation between the plates. Now look at this idea, V and D. V and D are proportional. So if capital E, electric field strength is constant, if electric field strength is constant, you can say that voltage and D are directly proportional. What it means, if you want to keep electric field strength constant, so if you want to keep it constant and you increase the separation, you have to increase the voltage. You people must have noticed that the walk-through gates are very narrow. They keep it narrow so that so less voltage is needed. Voltage and separation between the plates is directly proportional. So now you have to copy this screen. It's a straight line. Straight line means it's directly proportional. Now, if you people have copied, you people can update me on the chat, on the Zoom chat, I mean. So you have to update if you people have copied. This is a straight line. The topic is electric field between two parallel plates. If the field is uniform, you will get a straight line. You will get a straight line showing that V and D are directly proportional. Okay, that's good. So now we are talking about electric field between two plates, and I already said that you can imagine it like a walk-through gate. The gradient in our physics is a very important factor for every graph. gradient is equal to capital E. Gradient is equal to capital E. So gradient shows electric field strength. So now you have to copy this gradient also. Now let's move to our next case. This is case number 2. We have placed a positive charge. It's called point charge. How we know it's a point charge? The positive is at the center. If the positive, look at the screen, if the positive is at the center like this is a point charge. If the charge appear like this, okay? If the charge appear like this is if the charge appear like this is called an extended charge. So this is a point charge, and this is an extended charge. So we are starting case number 2. In parallel plates, we have placed a positive charge, and as you leave it here in case number 2, what will happen? The left plate will be repelling it. Look at this case. The plate on the left side will be repelling the charge, and the plate on the right side will be attracting it. What will happen? What will happen that the charge particle will now accelerate towards the negative plate. Give a side heading, case number 2. Give a side heading, case number 2, and copy this. Now, this is a situation where a positive charge is between the two plates. The positive charge will move towards the negative plate. It is being attracted, the left plate will be repelling and the right plate will be attracting. Test charge will accelerate towards the negative plate. So now this diagram can be now translated to this graph. Force is constant. Look at the straight line. The force is constant, and we can see that there is a separation from the positive plate. As the charge particle moves, as the charge particle move, separation from the positive plate increases. As the separation from the positive plate increases, what will happen? The force doesn't change. The total force remain the constant. Why the line is horizontal? The line is horizontal. The line is horizontal, which shows that force is constant. So now you have to copy this. You have to copy this. Force is constant. Already this is already answered that why there is an F1 and F2. One is coming from left side, which is a force of repulsion, and second is from right side, which is coming due to attraction. Good explanation already made. Good. Actually, now look at this idea. Force is constant. It's a straight line. Now look at this idea. The total force remains constant, E is equal to F upon Q. Now, what is electric field strength? Electric field strength is also called the signal strength. Electric field strength is also called the signal strength. So the signal strength does not change. Electric field strength remains constant. So our next concept for today, when a charged particle is moving, when a charged particle is moving in an electric field, when a charged particle is moving in an electric field from left to right, the resultant force does not change and the electric field strength also remains constant. You people have already copied the diagram, so copy you have to copy this also on the same diagram. You can make a new diagram if you want, but it's your choice. So you have to show the concept that electric field strength is constant. Now, look at this idea that we have a charge which is moving from left to right. Electric field strength, capital E, the signal strength is not changing because the lines are parallel and equidistant. So you have to copy this additional stuff also on the same diagram, or you can make a new diagram also. Now, let us put the graph again. Look at the screen. Capital E is constant. Capital E is constant. It's a straight line. Electric field strength is constant. Whenever something is constant, its graph is a horizontal line. So E is constant. What is E? Electric field strength. You have to copy this graph. Now look at our case number 3. Now in the case number 3, we have again two parallel plates. The formula E is equal to V upon D. What is V? V is the voltage across the plates. And what is small d? D is the separation. D is the separation between the plates. Now look at this idea. Now look at this. If capital V, if you want to keep the voltage constant, then E and D are inversely proportional. What's the meaning of E and D inversely proportional? It means that it means that if you bring the plates closer, electric field strength will increase. If you move the plates away from each other, electric field strength will decrease. So you have to give a side heading case number 3 and you have to copy this. Case number three, electric field strength is inversely proportional to the separation between the plates. What's the idea behind it? The same example, walk through gate, imagine it. If you bring the plates closer, you will get a stronger feel. And if you move the plates away from each other, you will get a weaker feel. That is why when you move the plates to closer, when you move the plates closer, you will get a stronger feel. And that is why these people, the security system, they always keep the plates as close as possible. Now look at this. uh, E and D are inversely proportional. This is a smooth curve showing inverse proportionality. Now you have to copy this sketch. Now this is a smooth curve. Now let us recollect our knowledge in this chapter. This is the second lecture. Now make a concept here. There are two formulas of electric field strength. Electric field strength has two formulas: F upon Q, Newton per Coulomb, and it is V upon D, volt per meter. So there are two situations. One is applied for a point charge and the right one is applied for parallel plates. This is like a consolidation concept. There are two formulas of electric field strength. You have to copy this. This is a case where you are showing there are two types of electric field and we can separate them out. Now let's move to the next concept. The AS version is over. I already had explained that in this chapter there are two versions. This chapter was for initially half in AS and half in A2. In 2022 they merged it and they put it together in A2. Now you should take a new page, A2 version electric field. Give the heading. A2 version electric field. Now I'm putting the first concept, it's Coulomb's law. This is the core topic of this chapter, and the whole chapter moves around it. This law is very similar to Newton's law of gravitation. I said last time, and I hope remember people would remember that electric field is a connecting chapter with gravitation. You will find many questions addressing electric field and magnetic field. So now you have to give the heading Coulomb's law. Now we are starting this title. As usual, there will be a statement. Coulomb's law is mainly interested. Coulomb's law is mainly interested in the behavior of charges that when they come close to each other, remember, like charges repel each other, and unlike charges always attract each other. Now we first put the statement. It's important. It has to be memorized. You will, if you have a good memory, you will identify when you're copying this, you will identify that this statement is very similar to Newton's law of gravitation. So now you have to copy this statement in inverted commas. Okay, once you people have copied the statement, you people can leave. The class is over for that. We have started Coulomb's law.